Hello, and welcome to the Physics, Frenzy, and Fun amusement park, where we bring physics and art into a frenzy of fun for you. Our park is proof that physics can go hand in hand with art as we use what we've learned in the classroom to bring our creativity to life. We'll be first going over the physics and details of each ride before giving a full demonstration of everything together. And first we have the pirate pendulum. The pirate ship is a point mast that is suspended from a string connected to the table. In order to make sure all values are consistent using the small angle approximation, the pendulum will only swing up to 20 degrees. This demonstrates oscillation as the mast is swinging from side to side. To calculate the period, we will use 2 pi multiplied by the square root of L over G. The length of the string is 0.3048 meters, and therefore the period is around 1.1 seconds. Then the pendulum will hit the call button on my phone, which makes another phone ring. When the cell phone begins the call, it communicates by transmitting electromagnetic waves through antennas in the phone to the other cell phone. By making a change in the electric field, a magnetic field is produced, and vice versa. This creates a pattern which we call the electromagnetic wave. In our phones, these electromagnetic waves contain the frequency, period, and amplitude of your voice, which is encoded and decoded between each phone.
Next up, we have the roller coaster. An object, which I will call object A, will start from rest at the top of the roller coaster. In the beginning, it would have a high potential energy relative to the ground. As the object rolls down, its potential energy is converted to kinetic due to conservation of energy, so its speed increases the further down it gets. This demonstrates the topic of energy. As for the calculations, half m times velocity of a squared is equal to mgh. So the velocity of a at the bottom is equal to the square root of 2gh. When object A travels and it reaches the end of the track, it will collide with another similar object, object B, that is originally stationary. After the collision, object B would move forward with a constant velocity. This demonstrates an inelastic collision with energy loss, and the concept of conservation of momentum is shown with the momentum of A before the collision is conserved and split between objects A and B afterwards, giving the originally stationary object B a velocity. For the calculations, m times the initial velocity of A is equal to m times the final velocity of A plus B, and the final velocity of B is equal to initial minus final velocity of A.
Another key component of our amusement park is Circuit Circle, which is our Ferris wheel. Starting off with a closed circuit that will power the motor to rotate the Ferris wheel, it consists of the battery pack that holds 98 volts, the motor attached to the cardboard, and the alligator cables that connect the components of the circuit. After powering on the battery pack, current travels through the circuit and motor. Besides the circuit aspect of the Ferris wheel, it also explores rotational motion. The equation for frequency is angular velocity W divided by 2 pi. The motor traveled at a speed of 61 rotations per minute. Multiplying this by 2 pi allows us to calculate the wheel's angular velocity to be 6.4 radians per second. Next, we have bumping bar magnets, the park's bumper car attraction. Here, we have magnets with opposing charges that evidently cause the cars to attract one another. As the cars attract, they form an inelastic collision. Total mechanical energy is not conserved in this collision, as it converts into thermal energy from the collision. The equation for the momentum of the total system is mass 1 times its initial velocity plus mass 2 times initial velocity, equal to the final velocity times mass 1 plus mass 2. The final velocity is shared by both masses because the two masses stick together to become one total mass after the completely inelastic collision occurs.
The last component of our amusement park is gravity drop, a pulley system. Several marbles roll into the cup, adding weight so that the force is redirected and the poster is revealed. The pulley is constructed using a wheel with rimmed edges on an axle threaded with a rope. The advantage of this is that it allows you to lift the other cup up using only half the force it would take to lift with your hands. For example, if you have an object that weighs 100 newtons, all it would take to lift the object in this pulley system are 50 newtons of force applied, increasing the mechanical advantage. And that's all we have for our Physics, Frenzy, and Fun amusement park.